Hi, this is Maria, and I'm going to teach you about how to name ionic compounds. Goals of this video: briefly reviewing how to figure out the most common ion of an element, how to correctly write the name given an ionic formula, and how to predict the correct ionic formula given a name. So, just to refresh your memory, figuring out common ions is just based off of the number of valence electrons an atom needs to either lose or gain to have a full outer valence shell. So if I'm looking at calcium, I know calcium has 2 valence electrons, so it's easiest to give up those 2 valence electrons, so it ends up having a charge of 2+. If I'm thinking about something like nitrogen, on the other hand, nitrogen has 5 valence electrons, and so it's far easier for nitrogen to gain 3 more electrons. So that's why nitrogen and phosphorus have a charge of 3- when we're thinking about those common ions. If this isn't familiar, you're going to need to refresh your memory. You need to know that for this particular video. So I would stop here and I would actually go back to those notes from Unit 2. For the chemical formulas, this is new. We haven't talked about this before, but I will tell you this. The easiest thing, subscripts tell you how many of each atom are found in a compound. So if I'm looking at barium iodide, and I'll talk more about that IDE ending, there's 1 barium and 2. That's it. If I'm talking about the strontium nitride, 2 strontiums, 3 nitrogens. Again, we'll talk about that IDE ending in a second. This last one right here is calcium nitrate. All you need to know is that when something's in parentheses, similar to like if you're in algebra, all you have to do is go, oh, well, there's a 2 on the outside of this, so I just have to multiply everything that's within the parentheses by the number that's on the outside. So in this particular case, I have to multiply everything that's inside the parentheses by 2. So outside of the parentheses, I have just 1 calcium, but within the parentheses, I have 2 nitrogens and 6 oxygens. All right, just keep that in mind going forward. So, ionic compounds. You're going to learn more and more about them this unit, but the quickest way to identify it based on just the formula, if you have a metal and a nonmetal, it's likely to be an ionic compound. So based on that, and probably by looking at a periodic table, which of the following of that list that I have right here are ionic compounds? You can pause here, just see if you can figure it out, and then here's the answers. So the ones that are ionic compounds are sodium chloride, potassium sulfate. Don't worry, you wouldn't know what the sulfate is yet. And then barium nitride. Water, although very important, is not an ionic compound. No metals present. And glucose, which is this particular compound, very important biology, but not an ionic compound. The most important thing that I need you to know before we talk about naming about ionic compounds is that although the pieces of the ionic compound are charged, the compound overall has a neutral charge. So if I'm thinking about sodium chloride, which you'll find very quickly is our favorite ionic compound to talk about, sodium I know has a +1 charge, chlorine has a -1 charge, and together they cancel out and they're 0. That's all you need to know from that. All right, so let's start with the easiest potential ionic compound. So if I'm thinking about sodium chloride, NaCl, it's easy enough. Just think about it like this. The first element in the formula, same as the atom name, so sodium. For the second one, this is a little trickier. The second element in the formula has to have an IDE ending. Chlorine would become chloride. Now don't worry, most of these are ones that are fairly intuitive. You'll pick them up really fast. But if you don't, there's a few that are a little weirder. We're just looking for effort. So you can't put chlorine, you have to put chloride when you're talking about a ionic compound. So once you've combined them, in this particular case, it's sodium chloride. All right, so I have some practice over here. I would go ahead, take a moment, pause the computer. You don't have to write the answers to the practice down, but at least say them out loud. Then, if you unpause here, here's the answers. All right, I hope you did well. Okay, next potential situation. So if the cation remember that's the positively charged ion, has multiple possible charges. So if you remember which particular family in the periodic table has that happen, that's the transition metals. So almost all transition metals have multiple possible charges. So these rules essentially apply for transition metal containing ionic compounds. So if I use this particular example, so FeCl2, again, just as before, the first element in the formula is the same as the atom name. So Fe is iron. And then the second element in the formula has to have an IDE ending. So again, chlorine becomes chloride. Now this is where it's less intuitive. You have to figure out the charge on the cation. Since there are two chloride ions, both of them have a charge of -1. So in total I have -2. And since all ionic compounds are neutral, so essentially I know my positive charge plus my negative charge must equal 0, that means that the charge on iron must be 2+. Then you're going to need to combine them. And in this particular case, you have to use Roman numerals to indicate charge on cations. Must, must, must. If you do not include this, it's incorrect and will be marked wrong. People always ask me, but why, Maria? That doesn't make any sense. I wrote iron chloride. Why did I need that too? Well, as you can see here, iron 2 chloride and iron 3 chloride are very, very different compounds. You can tell that just from their color alone. And because they're very different compounds, you need to indicate the charge on that iron. So just keep that in mind. All right, I have some practice below right here. Again, I'd recommend pausing it here. All right, welcome back. Here's the answers. And I hope, again, hopefully you got them all right. Again, I do want to call attention to 3 and 4 here. You see that oxide is a weird one. I know that one's a little less intuitive. And the phosphide, we're not looking for perfect spelling on these. So as long as you don't spell it oxygen or phosphorus, then you're okay. All right, so again, let's think about it from the simpler perspective. So given a name, could you write the formula of an ionic compound? So I'm going to use the example of rubidium sulfide. First thing you would want to do, write out the charge on the first element. So rubidium, that translates to Rb, which has a +1 charge. Then writing out the charge on the second element. Well, I know that sulfide translates to sulfur, which has S as a symbol, and that particular element has a 2- charge. And again, you have to combine them to make sure that you have a neutral compound. So I think of it as, oh, I have a sulfur that's -2, and rubidium is only +1. So, I'm going to need 2 rubidiums, that's why I have this subscript here, to cancel out that charge from the sulfur. Always, 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 especially when you're first doing ionic compound naming, double check to make sure that you have that neutral compound. So just the same as I did before. Oh, okay, I have 2 rubidiums, each of them are +1, and then I have 1 sulfur, which is -2. When I add those together, I get 0. A way to think of this that I think is the easiest way is the crisscross method. So if I think about that, that's just, if I'm looking at aluminum, well, I know, aluminum has a 3+ charge. Oxygen has a 2- charge. All I have to do, switch the numbers. So essentially, that means I have 2 aluminums because I had 2- on oxygen, and 3 oxygens because there was a 3+ on aluminum. Remember, this does not mean moving who's positive and who's negative. It's just switching the numbers. It's the fastest way to do this. If this is too confusing, that's fine. I would stick to the method that I wrote out before. Usually, though, this is a very handy, helpful shortcut. Either way, make sure you practice it. Again, you don't have to write down this, but at least make sure you practice it out loud. So I would pause the video right here. Welcome back. And here's the practice answers for the practice up above here. Okay. Again, what if it has multiple possible charges? Also known as, does it have a transition metal? So if I'm looking at vanadium V oxide, step 1, again, start out by writing out the charge on the 2 elements. Easy enough, because vanadium actually has the answer for what the charge on it is in the problem. It has the Roman numeral V, which, if you remember your Roman numerals, means 5. So it has a charge of 5 plus, because remember, all metals, they love to give up those electrons, which means that they have a positively charged cation. Oxygen, remember that means oxide, that translates to oxygen. And since that translates to oxygen, I know oxygen has a charge of 2 minus when it's in its ion form. Again, combine it to make a neutral compound. You can use that crisscross method that we just talked about for the previous page. And make sure that your compound is actually neutral. So let's walk through this and double check and make sure. So I put V2O5. Okay, well, I have 2 vanadiums. Each of those have a positive 5 charge. And then I have 5 oxygens, each of which have a 2 minus charge. Okay, so plus 10, negative 10. Yep, cancels out, gives me a 0. Perfect. Again, it's really important to have that Roman numeral in there, because vanadium oxide is a very different compound than vanadium 4 oxide. So vanadium 5 oxide, vanadium 4 oxide, real important. All right, I would recommend pausing for the practice again, and I have some practice right here. Welcome back. I hope you got everything correct again. Awesome. All right, so I just want to sum up with some important rules. The cation, if you notice in every single one, that positively charged ion must be written first. Must. Always, always remember to check if one of the metals that's in your compound is a transition metal. Really, really important. And then pay close attention to the compound charges. Your compound has to be neutral. Has to be. All right, so with that, if I tell you that there's an anion, and it's called hydroxide, so remember anions are negatively charged, and it has a formula of OH minus 1. So it's what we call a polyatomic anion. You can figure out what the word polyatomic means for yourself. Try and name the compounds, or come up with the formula, just from the problems below. So there's these 4 problems. We'll discuss the answers to those problems in class. That's all for now. Remember, write down any questions that you have. Your teacher will help you with them tomorrow. And I look forward to seeing you again.